Supla is a Polish building automation system which has been largely developed by the community gathered on forum supla.org for over 5 years. One of the amazing forum projects that was made thanks to the work of the users Clef, Spablo, Krycha88 and Gural64 is GUI generic. This firmware allows us to customize the amount and types of functions that we can implement almost in all modules like ESP8266, ESP8285 and many others. GUI generic online generator, which enables to generate the tailored firmware, has been recently developed. In this material, I will present step by step how to generate the right firmware and upload it to the device. In the case of the hardware needed to upload GUI generic to ESP, there are two options. The first is to buy a USB connection capable board such as Wemos D1 Mini. The second one, a bit more complicated, is to buy a raw ESP module, for example ESP01, and a special programmer which will be described in a moment. Of course, if anyone has a complete device such as Sonoff Yunshan or Electro Dragon, a programmer will be necessary as well. The first step will be to launch the browser on the computer and download the firmware upload tool. In order to do this, go to GitHub NodeMCU PyFlasher, the link to which is in the description, and download the appropriate installation file. For Windows, it will be an exe file. Open the downloaded file and close the Windows Defender notification. On the VirusTotal.com website, it is possible to make sure that the file is completely safe. Then, enter the so-called GUI generic builder available on GUI generic builder supla.io. This is where you can generate firmware for a module with selected functions. In the first case presented in the guide, you will upload the firmware to the ESP01 module and in the second to the Wemos D1 Mini. For those who are just starting with Supla, I recommend Wemos. It's much easier to program because you need only a USB cable. In the case of raw boards such as ESP01 and complete devices, for example Sonoff, a programmer will be needed. One of the recommended programmers is CP2102, available for over few euros on a well-known auction website. Since the theoretical part is already behind us, we can move on to specifics. In the presented example, I will generate the firmware that enables to control the relays, and in the case of Wemos, we will add the possibility to turn them on by using buttons. For this purpose, I choose the right board. Both ESP01 and Wemos are ESP8266. We leave the default value of 1 MB in the flash memory field. We leave the first 4 items in the default state, which is on. Now we can choose the functions that GUI generic should enable. As I have promised, relays will go first, so we select this option. We go to the bottom of the page and click generate. We wait a while and save the generated file to the selected place on the computer, in my case on the desktop. Now we need to connect the module with the programmer. Connect the VCC I/O and ground pins to the ESP01 power and ground pins respectively. Connect the TXD pin of the programmer to the RX ESP pin and the RXD of the programmer to the TX ESP. Find a free cable which will connect the GPIO0 pin with ground while connecting ESP to the computer. This will enable to enter the module into the programming mode. If the module is already connected, press the Windows button and the X button and enter the device manager. You find the ports item and open the list. There we need to find the COM1 communication port and the second one, which is the port on which our programmer is placed. In my case, it's COM11. We launch NodeMCU PyFlasher and select the port which has just been read out. If it isn't on the list, click the reload button. Then select the generated firmware. In the baud rate field, select 115,200. Select dual output as the flashing mode and select the Yes Wipe All Data field in the Erase Flash section. Make sure that everything has been filled correctly and click the Flash NodeMCU button. While the firmware is being uploaded, the diode on the module should flash. If we see such patterns in the console, it means that there is no connection with the module. After uploading the firmware, disconnect the ESP01 power supply and reconnect it. The board should transmit the Wi-Fi network. Enter the Supla application and click on the expanding bar. Click Add a device and follow the instructions. We click Start. After the network appears in the window, click Connect. If we see such information, it means our device has been successfully registered in the cloud. We can check it by logging into the cloud and checking if the new device called GUI generic has appeared on the list of devices. If we can see our device, we delete it and make sure that device registration is turned on. We are going to need a computer to complete the following steps. After waiting about a minute after registering a device, start the browser and enter supla.local, and if the browser searches for a phrase in the search engine, then we must enter the full address, which is http://supla.local. It may happen that due to the limitations of our hardware or software, we are not able to get to the desirable page. In this case, it is worth installing the Bonjour service from Apple. If installing doesn't help, then it remains to look to the IP address on the router's website and enter it in the browser. We are on the module configuration page. We log in using the default login and password, which is admin and pass respectively. Currently, all the data necessary to register are entered, so we only have to configure the pins and the functions. The first element that can be modified is the name of the module in the cloud. Next, we can change the login and password to access the module. Now, enter the settings and assign the right pins to the right functions. As you can see, after setting the relays, I can enter the option of individual relays, and for each of them, I can set whether it should be triggered with a low or high state and set the behavior of the relay after turning on after a power loss. We must remember one more important thing. In order for the module not to transmit the Wi-Fi network continuously, we need to configure the pin, which will enter the configuration mode, so now we go to the configuration section. By selecting a given pin from the list next to the LED item, we determine which pin is the LED signaling the module status. ESP modules have LED on them and it is on GPIO2. Unfortunately, due to the limitations of ESP01, we must keep it off. In the state control item, we can select the state of the ESP pin, which will be responsible for blinking the LED. For ESP modules, we just leave low. The last step is to select the method of activating the configuration mode. As the tutorial covers the basic functions of GUI generic, let me skip the last two options and leave them in their default state. Remember to click Save after each change. After entering the right settings, click the Restart button. When the module restarts, we check in the cloud if it has functions we want. We disconnect the module from the power supply and connect the proper devices. In my case, it will be two relays. After connecting all the elements, connect the module to the power supply. From now on, we should be able to use the device from within the application. If we want to change any board settings, we enter in the browser its IP, which we can check by clicking the eye icon of our module channel in the Supla application. Of course, the IP must be entered into the browser launched on the device connected to the same network as the module. Before we change any setting, we remove the device from the cloud and turn on device registration. After making the right changes, click Save and Restart. The device should reappear in the cloud. As you can see, while turning on the power, the relay connected to GPIO 0 turns on for a moment. This is due to the wrong pin selection. If someone wants to learn more about the selection of pins, the description includes a link to the article explaining it. In short, ESP01 isn't quite right for controlling relays. However, there is a popular function among Supla users for which this module is used. It is about measuring the temperature. The recommended sensor is DS18B20, which is known for its stable work and accurate measurement. It is available for a few euros on a well-known auction website. There are also already waterproof solutions, a bit more expensive but perfect for using outdoors. In the material, I show the connection of a waterproof variant of this sensor, but it is the same as the one without the case. Let's get to the point. We generate the firmware. Select ESP8266 and leave the default value in the flash memory field. We also leave the first four options unchanged. In the one wire section, select DS18B20 item to yes. Click on Generate and download the file. We connect ESP01 to CP2102 in the same way as before. While connecting the programmer to the computer, link GPIO 0 to ground in order to enter ESP into the programming mode. Press the Windows button and the X button and enter the device manager. We find the ports item and open the list. By default, we should find the COM1 communication port and the second one, which is the port on which our programmer is placed. In my case, it's COM11. We launch NodeMCU PyFlasher and select the port that has been just read. Then select the generated firmware. In the baud rate field, select 115,200. Select dual output as the flashing mode, and in the erase flash section, select the yes wipes all data field. We check if we have entered everything correctly and click the Flash Node MCU button. While the firmware is being uploaded, the diode on the module should flash. If we see such patterns in the console, it means that there is no connection with the module. In my case, such situation didn't take place. Everything was uploaded correctly. We disconnect ESP from the power supply and connect it again. We launch the application and go through the configuration process. We enter the cloud and check if the module has been added. We delete it and make sure that device registration is active. After waiting about a minute after registering the device, start the browser and enter supla.local. And if the browser searches for a phrase in the search engine, then we have to enter the full address manually, which is http://supla.local. In the previous section, I explained what to do in case of any problems. We log in using the default login and password, which is admin and pass respectively. Although this isn't a necessary element, I recommend changing the module name. Select pin to which our temperature sensor will be connected. I recommend choosing GPIO2. Save and go to selecting the module configuration button. Due to the fact that we have a limited pool of pins, we must select GPIO0. ESP modules have LED on them and it is on GPIO2. Unfortunately, due to the limitations of ESP01, we must keep it off. We click Save and Restart. We check if the module has re-registered in the cloud with the selected function. If it has, disconnect the module from the power supply and connect the DS to the right pin. Remember to pull up the thermometer communication line to the power line of the ESP with a 4.7 kΩ resistor. You can read more about pull-up resistors and their selection in the article, the link to which is in the description. When everything is connected, we turn on ESP. We enter the Supla application and check if everything is working properly. If we see a value of minus 273 degrees Celsius, it means that DS isn't properly connected. If we want to change any board settings, we enter in the browser its IP, which we can check by clicking the eye icon of our module channel in the Supla application. Of course, the IP must be entered into the browser launched on the device connected to the same network as the module. Before we change any setting, we remove the device from the cloud and turn on device registration. After making the right changes, click Save and Restart. The device should reappear in the cloud. In the case of uploading GUI generic on Wemos, many things are the same, so in this part, I will short circuit in places where the procedure is repeated. We generate the firmware. We choose ESP8266, flash memory, we leave the default state. Of course, we leave the first 4 options on yes by default. Select the relays and buttons fields to yes. Click generate and download the file. We connect Wemos to the computer. We don't need any adapters here. A regular USB cable is enough. Of course, it must be a cable that has at least 4 wires, that is, one that can transmit data. Click the Windows and X button and enter the device manager. We find the ports item and open the list. We should find the COM1 communication port and the second one, which is the port on which our program is placed. In my case, it is COM12. We launch Node MCU by Flasher and select the port that has just been read out. Then select the generated firmware. In the baud rate field, select 115,200. Select dual output as the flashing mode and select the yes wipes all data field in the erase flash section. Make sure that everything has been completed correctly and click the Flash Node MCU button. While the firmware is being uploaded, the diode on the module should flash. If we see such patterns in the console, it means that there is no connection with the module. In my case, such situation didn't take place, because everything was uploaded correctly. We disconnect Wemos from the power supply and connect it again. We launch the application and go through the configuration process. We enter the cloud and check if the module has been added. We delete it and make sure that device registration is active. After waiting about a minute after registering the device, start the browser and enter supla.local. And if the browser searches for a phrase in the search engine, then we have to enter the full address manually, which is http://supla.local. In the first part, I explain what to do in case of any problems. We log in using the default login and password, which is admin and pass respectively. We configure pin settings and connected devices. Save and restart. We go to the configuration field and, if we want to, we turn on the LED on Wemos, signaling its state by selecting GPIO2 from the list. Select the button for turning on the module configuration mode. We can choose the button that we use to turn on the relay. This is a very useful option because if the module is installed permanently, we can easily enter the configuration mode using the available buttons. We connect Wemos to the devices, of course with the power off. Turn it on and voila, everything works as it should. The buttons aren't visible in the cloud because they are elements that work locally. They are assigned automatically during configuration in the GUI. So, if we have two relays, button 1 automatically responds to the first relay and the second to the second. If we have a ready board, for example Sonoff or Yunshan, we can generate the firmware with predefined settings. For this purpose, we choose our board in Builder in the board section. Uploading is the same as I have described for the ESP01. We need a programmer. I recommend CP2102. Connect the TX pin of the programmer to the RX pin of the device and the RX of the programmer to the TX. The VCC of the programmer to the power of the board and the ground to its ground. Of course, always check before connecting that the programmer gives 3.3 volts on the VCC pin, not 5. When connecting the programmer previously connected to the module to USB, link the GPIO 0 pin to ground. Next, the process looks like the one described earlier. GUI generic for ready boards like those is extremely interesting solution because it enables to add additional features. For example, if we have Sonoff, besides adding its basic function to Supla, which is relay, we can enrich it with the thermometer. The last element worth paying attention to is the tools section. We have access to several, as the name suggests, tools. We can save the set configuration of pins and functions in the .dat file. We can also load such configuration. We have the possibility to reset the device settings and restore the factory settings. And now, the icing on the cake. The OTA update that is over the air. GUI Generic allows you to update the module wirelessly without losing saved data. In order to do this, go to the GUI Generic Builder website and generate the firmware with the same functions as we have on the module. Here it is very important to generate a 1 MB file. In my case of Wemos, that is 2 relays and 2 buttons, we select ESP8266, leave the default values in the flash memory field and the other 4 options. We select relays and buttons to yes. We generate the file and download it to the device. Now we enter the module's GUI via the IP address, which can be found in the Supla application after clicking the eye icon in the channel of our module. Log in and go to the tool and update fields. We will be asked to enter the previously defined login data. By default, it is admin as a login and pass as a password. Select the GUI Generic Updater file available for download on the GUI Generic Builder website. Wait for a while and select the file that has just been generated. We click Update and wait. If we did everything right, we should see such a window and after a while, GUI. As you can see, updating the GUI generic version isn't so difficult as long as we are patient and follow the instructions. GUI Generic is a very useful firmware. It can have a lot of applications in many devices and the pool of operated sensors and functionalities is constantly expanding. You can find test versions of GUI Generic on GUI Generic Builder Supla io/test.php, link in the description. In case of any problems, post on forum supla.org in the dedicated section. And if someone wants to support the creators of the project, the description includes a link to the fundraiser. Thank you for your attention and good luck.